Hi everybody, it's Mr. Gar again. Today we're going to be looking at 8.3 day 1, using trig functions with our general angles. Okay, so to start with this lesson, we're going to model -4, 3 as a point on the terminal side of an angle, and then find the 6 trig functions of the angle formed. So if I do this, we're going to model this on here on a corner grid. I'm going 1, 2, 3, 4, 1, 2, 3. Here's my point here. So when I refer to the terminal side, I am referring to going from the origin to that point like that right there. Okay? So if I kind of measure it out here, this is 3 and this is a -4. And it's important to make it negative in that direction. So if I think about my 6 trig functions, there's one thing I need, and that's my last side, my hypotenuse here. So when I look at this side here, that's going to be 3 squared plus a -4 squared is equal to r squared. We'll call it r. So when I do that one, I got 9 plus 16 equals r squared. 25 equals r squared, and then I square root it to get 5 for r. So we got 5 there. So now I have enough to do all of my different trig ratios. So sine of theta. Now, one thing that's important is we are going to refer to this as my theta. This is the angle it makes with my terminal side and the x-axis. So it's always drawn to the x-axis like that. So when I look at that there, sine theta is going to be opposite over hypotenuse, so that's 3/5. Cosine theta is going to be adjacent over hypotenuse. Now, in this case, adjacent side is -4. I'm going to keep that negative sign. So it's going to be -4 over 5. Okay? And then tangent theta is going to be opposite 3 over my adjacent -4. Okay? Then we're going to do our 3 reciprocals. Okay? So for sine, we're going to go to cosecant of theta. So we're just going to flip that over, make it 5/3. We got secant theta. So it'll be a -5 over 4. And then cotangent theta is equal to a -4 over 3. Okay? Now, before we move on, one quick thing to notice. What happens when you divide the sine by cosine? So I'm just going to pick, we got 3/5 divided by a -4/5. Well, that's the same as 3/5 multiplied by -5/4. Those cancel out, nothing else changes, so I get a -3/4. That, same thing here. So this is actually a nice little thing to recognize as you move on, is that tangent of theta is the same as the sine of theta divided by the cosine of theta. So we can always do that to compare those two. All right. So let's find our 6 trig functions for some classic special triangles, 30, 60, 30, 60, 90, and a 45, 45, 90. So these are going to be special angles, and we always want to give exact answers. Okay? So normally we would do something like this. For a 30, 60, 90, I would do 1, 1, root 2. But if we decide to take everything here divided by root 2, we get 1 root 2 over 2, root 2 over 2. Same idea here. This is normally, I would say it looks like this. It'd be 1, 2, root 3. But instead of that, we divided everything by root 3 here. Or sorry, no. We divided everything by 2. We want to make this a 1 right here. So everything else gets divided by 2. Now, how does this help us? These are not things you have to commit to memory, but this is something that is going to be helpful as we move forward. So if we look at something that is 30 degrees angle, so in terms of my terminal side, it would be something like this. So that's pi over 6 radians. It's also sine of that is 1/2 because it would be like 1 over 2. Here's the thing, you can always model the triangle that it's giving you. So it gives you 30 degrees. You would draw something like this where it's 30 degrees. 45 degrees would be more like this in the middle. Okay, that's 1, 1, root 2. Then 60 degrees would be more like this. 1, 2, root 3. Okay, so all of these values here are just adjusting these right here. So we just always want to make our hypotenuse 1 is the idea. So that's 1, and so on. Okay, 45 is pi over 4, 60 is pi over 3, and we get these varieties here. I'm not going to spend a lot of time on there because I like to just kind of first model it with a triangle before I start doing anything with those parts. So for example, here, you use this chart to find exact values of the six trig functions for these special angles. Okay, so evaluate, give exact answers. So I have the cosine of pi over 3. Now, when you look at the chart, pi over 3 is that one right there. Cosine is right there. It's 1/2. So I could just take 1/2 and I'm done. But I like to quickly model this. So pi over 3 is going to be like this. 60, 30, 30, 60, 90 triangle like that. So it's going to be 1, 2, root 3. So I want to do cosine of this. Cosine is adjacent 1 divided by hypotenuse 2. So that's just another way I can get the same kind of answer. Just trying to show more than one method. Okay, for this one, I'm just going to use the chart to make it a little bit quicker. So pi over 6, I want to find tangent. So tangent, so we got pi over 6. Tangent is root 3 over 3. Okay, so we're done there. And then finally, the secant of 45. Now, secant, keep in mind on here, secant is the reciprocal of cosine. Okay, so there it is right there. So I'm just going to go ahead and rewrite that one down in this case. So it's 2 root 3 over 3. All right. Or wait, secant. Oh, sorry, I was looking at the wrong one. Secant of 45 degrees. Okay, that's root 2. My bad. Okay, root 2. All right, so you're going to get a cheat sheet for this. The circle on it in the cheat sheet is what's called the unit circle. The coordinates around the unit circle represent the sine and cosine ratios for a given angle. And it's always going to be x is going to equal to the cosine of theta and y is equal to the sine of theta. So when we look at this right here, if we want to evaluate using our unit circle idea, we want to find the cosine of 45 degrees. So cosine of 45, here's 45 degrees. Cosine is the very first number in that x and y coordinate. So it's root 2 over 2. Now we want to do pi over 6. Pi over 6 is right here. Not, or we want to find sine. Sine is the second value. So it always goes cosine comma sine. So let me write that down too. Cosine comma sine theta. That's how the coordinates are on the unit circle like that. So for pi over 6, we're going to go right to sine. So that's going to be 1/2. And that's it. Okay. So the angles 0, 90, 180, and 270 are called quadrantal angles. Quadrantal angles. I think I'm saying that correct, but that's, it's more important that we recognize what they are for their relationships here. So they are very important for our study. So we look at radian measures of this diagram. The quadrantal angles are the ones that are on the axes, on x or y axes. Okay. So when we look at this, 90 degrees, 180, 270, and then both 0 and 360. Now, when we do this in terms of radians, we start at 0. This is pi over 2. This is, oops, not 3 pi. That's just pi. What am I doing here? And then this is 3 pi over 2. And then we're back here for 2 pi for 360. So that's all we're doing here. We're just adding our radian measures because we can just kind of think of that along with our chart from before too. Now, it's also important to recognize that these are points on this unit circle here, 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 and here. So the point here is 0, 1, negative 1, 0, 0, negative 1, and 1, 0. Okay. I'm still going to use the same exact thing of cosine comma sine for our coordinates. Okay, so when I look at here, I want to find our 6 ratios for theta is equal to 3 pi over 2. So 3 pi over 2, that's first starting with sine. Sine is negative 1. So we got a negative 1 there. Cosine is x. X in this case is just 0. Now remember from before, tangent, we don't have a direct way of doing that with the unit circle, but we can do sine divided by cosine. Okay, so I do that here, I would take -1 divided by 0, which is undefined. Oops. Okay, it's undefined. Okay, cosecant, that is the reciprocal of -1/2, so that stays at -1/2. This is 0, so this would technically be 1 over 0, and that is also undefined. And then the cotangent of 0 would be like 0 over -1, which is 0. Come here, you. There we go. All right, let's do 180 degrees now. So 180 degrees on right here, it's -1, 0. So sine is going to be 0. Cosine is -1. Tangent is sine divided by cosine, which ends up being 0. Here for cosecant, if I do 1 over 0, that's not allowed, so we're going to say it's undefined. Okay, secant is the reciprocal of cosine, so that's going to just stay in -1. And then tangents or cotangent is the reciprocal for tangent. So that'd be 1 over 0 again, which is undefined. All right. So here's a nice little overview of our unit circle here. So feel free to pause this, come back to it, but this is very helpful. I'm also going to have this posted or printed up and given to you as well. So just make sure you recognize some of the patterns here. Like we have 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. Okay. If we take this and split it up, we can split up by 30 degrees, which is also pi over 6. Then the next one that's related to 30 degrees would be 5 pi over 6 and 150, and so on. All right, so that's our practice today. We're understanding our general angles on our coordinate grid and how this might help us if we're looking at a unit circle. Okay, that's it for today. Take care, everyone.